Hello, hello, hello. Uh, Today we're going to talk about the second law of motion. The first thing I need you to do is to watch recording 125. This explains what you should do in this lab. What you're going to need is you're going to need some type of yardstick. You're going to need or meter stick. If you don't have that, a simple board will work. You just need to have some string, some tape, three marbles of the same size if you have it, or three beads that would be big enough to roll. Um, and you need a styrofoam coffee cup with a little hole cut out, and you'll understand what to do in this recording here. If you have questions, please ask. If you have those items, great. Try to just make it work with what you have. It must be a light cup that you use it with, and styrofoam, plastic, whatever it might be. It's better with styrofoam, it's much lighter. I was using a plastic cup on here as a demonstration, but a styrofoam cup would be better. And you have to cut a little notch in it and so on. Just watch the recording. You're going to do this lab, set this up however you want to. You also need to have something to measure a little distance. You can use a tape measure, maybe from a toolbox, anything that has something that you can measure either in inches or meters, or the metric. If it's metric, it's better than having inches, okay? Because then you're going to be trying to measure eighth of an inch and quarter inch, but that's fine if you have it. Okay, so let me get on with the lab sheet. Okay, so we got three lab sheets here. And these lab sheets, I'm going to open each one up and explain what you need to do. Here, first it says, how much does the amount of mass of an object in motion affect its tendency to remain in motion? So, right here, you could do this actually later. It says, how much does the amount of mass of the body in motion affect the tendency to remain in motion? So you can try to answer that. So in other words, if you have an object that is heavier and you set it in motion, how much farther would it move if it was um, lighter versus heavy? So would a heavy object move farther than a lighter object given the same force you put on it? So that's what this question is. Okay. Here's things that you need to have in order to do the lab. Actually, if you have 1 meter stick, would be great. Three marbles, yes. String, yes. You really don't need a wooden block, but you do need a cup, a paper cup, which is right here. And here they use rubber bands for what it is, but tape will work just fine too. If you want to use rubber bands, go right ahead. But you will see in the video how that is done. Then you have a styrofoam cup and make a little hole in the bottom. You'll see that in the video. Um, Use a styrofoam cup if you can. A small coffee cup would be great. Use whatever you have at your house if you're distance. And then just read through this and you can understand what you need to do. Now, page 2 of this, we are, oops, wrong one, apologize. You are recording how far your cup is going to move in 5 trials, not 3. I believe I said 3 on the other video. I'm not redoing it. I just messed up. Everybody messes up. I don't care. So do 5 trials of what you see that I'm doing with the marble. And then once you do all 5, put them in here and then add them up, divide by 5, and you'll get your average. Same thing with using 2 marbles. You'll see in the video how I explain to do it. And then 3 marbles. How far the cup moves with 3 marbles and then add all 5 of these up, divide by 5, and you get your average. Okay? So you'll see exactly what I asked for. If you have a question, please do. I may be forgetting something, but doing these videos, nothing's perfect. Now, after you have done that and you got your averages right here, then make a graph. Here you can have distances. So you can break this up depending upon what your distances are, figure out where you can label so many millimeters over here, or centimeters possibly, or inches, or you could have half an inch, 2 inches, 3 inches, 4 inches, and try to divide these lines up to represent that. And on the bottom here, you could have possibly, it can be a bar graph if you wish. You can make 2 of these spaces 1 bar going up to the certain distance. So this would be for 1 marble. Then over here, somewhere, 2 marbles label. This over here, 3 marbles. And then you're going to do a bar graph with the information up here, the distance that 1 marble moved that cup on average would be here, right? Going up with the distance on this side. 2 marbles here going up, and 3 marbles. And you would have that here with a bar going up. So that's how you do that one. And I'm going to go to the next and last one. And this says, how does increasing the mass or more marbles affect the object, the cup, in motion, right? So how does increasing from 1 marble to 2 to 3 affect the object's motion? And then right down here, what you do is you're going to write kind of a short paragraph answering the original question, describe whether or not your data supports the hypothesis, and use actual data from the investigation. What does that mean? That means from that first sheet, when you wrote your hypothesis about what you think how mass affects moving an object, you're going to just you're going to tell whether or not you were correct. If you said, well, the more mass, the farther it's going to go. If that's what you said, then just explain, is that true? After you did the lab, did that actually happen to show that that actually took place? Just write a brief explanation. Do it neatly so that it can be read and that I can read it. And always do the best job you can in writing so that it can be read by everyone. Keep the letters on the line. For some of you, might be hard. Do that. Make sure the letters are neat so you can read it, and do your best at spelling. Okay? If you have any questions, please ask.